Hi, I'm Paul Mason, and this is Ganymede in a nutshell. Ganymede is one of the four moons of Jupiter discovered by Galileo in January 1610. And those are from closest to Jupiter outwards, Io or Io, Europa, Ganymede, and Callisto. And this is a series of images taken from a telescope covering a couple of days as we see the planets orbit Jupiter. The moons orbiting Jupiter. So Ganymede is the largest and most massive moon, not only of Jupiter, of the entire solar system. And here's an image of Jupiter with the shadow of Ganymede. This is not Ganymede, but the shadow of Ganymede on the Great Red Spot. And so you can see that it is a little bit smaller than the Great Red Spot of Jupiter and much smaller than Jupiter. So if we want to think about Ganymede in terms of the Earth, we see that it's between the size and mass of the Earth and the Moon. Now, the Earth is about 4 times larger, maybe about 3.5 times larger than the Moon in diameter, whereas Ganymede is about 40% this radius of, or diameter of Earth. And Ganymede is about twice the mass of the Moon, about twice the mass of the Moon, and 1.5 times the diameter of the Moon. So Ganymede is indeed a large moon, and it is different than these objects, though, because Ganymede is made of about half rock and half ice. It's the largest moon in the solar system, and because it's half ice and half rock, its density is in between ice and rock. Ice is a density of 1 gram per centimeter cube. Rock is anywhere from 2 to 3 grams per centimeter cube, depending on the type of rock. And so a density of 1.9 puts it kind of in the middle. So it is a very icy planet in terms of the surface features. Deeper down, there is more rock and even iron down lower. But on the surface, there is a heavily cratered, old, dark terrain. And we call it old because there are lots of craters, and that means there has not been much change on the surface. And we can see a lot of that here. About 1/3 of the surface is covered by this dark terrain, but it's mixed in a very complicated way with bright terrain. There's very bright features. These are impact features from comets hitting Ganymede and leaving those bright icy marks. Some of this dark terrain is seen here next to bright terrain, which looks very different. The dark terrain has the heavily cratered areas, not very smooth. This light terrain is much smoother. It's very indicative of ice flows seen, for instance, on Antarctica or in the Arctic on Earth. But there are lots of craters in even here, indicating it's still a very, very old surface. A lot of these craters happened over a period of probably billions of years. And but a much older surface, several billions of years old, is indicated by the dark terrain. So Ganymede has plate tectonics and that means the ice on the surface is moving in and crashing into each other, forming ridges, and there's some heating from the tidal interactions between Jupiter and the planet Ganymede, and the planets Io, Europa, and Ganymede all orbit in resonance due to tidal interactions and orbital interactions between the moons. And this resonance is 1-to-1 for Io, Europa 2-to-1, and Ganymede 4-to-1, meaning for every trip that it takes Io to orbit, which is about 1.88 days, it takes twice as long for Europa to orbit, and 4 times as long for Ganymede to orbit. Now the fourth moon, Callisto, does orbit further out, orbiting out about pretty far out about here, but it is not in resonance with the other 3. The structure of Ganymede is differentiated, which means the heavy material has fallen to the center and the lighter material has risen to the top. The iron core, that's because it has been melted in the past, allows that differentiation to take place. There's an iron core that's solid in the center, surrounded by a liquid core that has iron and iron sulfide. There is a mantle, which is rocky above that, and then a tetragonal ice, which is also a layer of ice here above the mantle in very high pressure situation. Above that, a saltwater ocean, and this ocean is probably has as much or more water than the entire oceans of the Earth, all of the oceans of the Earth. Above that, a thinner layer of ice, maybe a few even 100 miles thick or kilometers thick, and so then the surface has this light and dark terrain with grooves indicating that the ice moves around on the surface, having plate tectonics. So there's 2 features of Ganymede that are actually very similar to Earth in some way, that is that because of the structure, there is a magnetic dynamo, and it creates a magnetic field of Ganymede, and I'll mention that in a minute, and as well as the plate tectonics which are occurring on the surface. The difference is on Ganymede, the plate tectonics are ice plates smashing against each other and forming the strange features we see here. On Earth, we have plate tectonics, and that forms the mountain chains and other features. So Ganymede is the only moon in the solar system with plate tectonics, and the Earth is the only planet in the solar system with plate tectonics. But there is the difference with rock versus ice tectonics. Here we can see some images from the Galileo spacecraft of impact craters. So we can see that this icy terrain is here, but it is not new. It's still very old, ice flows and impact craters that have occurred more recently than the heating or the flows that we see here. So both the younger and older regions of Ganymede surface are still very old surfaces. By old and young surfaces, I don't mean having to do with the age of the planet, our moon in those cases. The young surface of the Earth is caused by erosion, and it's very young, and the Earth is constantly changing whereas the Earth and Ganymede and the other objects in the solar system are all about the same age, at about 4.5 billion years. But the surface of some of these objects has not changed very much in millions or hundreds of millions or billions of years. And so that's what we mean by an old surface versus a young surface. And so Ganymede has a combination of both. Ganymede has ultra thin atmosphere of oxygen, and this results from ultraviolet light from the sun, which breaks apart ice molecules in the surface. And from the H2O molecule, the hydrogen escapes the low surface gravity of Ganymede, but the oxygen does not escape so easily. And so it is retained as an atmosphere, but it's a very thin atmosphere. We would consider it to be a vacuum. It's so thin here on Earth, but it is a measurable atmosphere. And one other thing that we have connected with that is the Aurora on Ganymede. From the Hubble Space Telescope image, we see overlaid with the Galileo spacecraft image, aurora, which are occurring above the surface in the thin atmosphere and magnetosphere of Ganymede. So Ganymede has a magnetic field similar to the process which makes a magnetic field on Earth, and Ganymede has aurora, which we can see, and as aurora are a smoking gun, as it were, to the magnetic field being generated in the center. So this is Ganymede in a nutshell.